Now we're ready to talk about what unit of measurement we use in chemistry. Now, we can't use a scale or we can't use a balance to weigh atoms individually, so we have to use another way. And so the method that we use is that we use something called a mole. MOLE, just like the animal. All right, so the way that we define a mole is that it's the amount of substance that contains as many atoms or molecules or ions or particles, whatever you want to call it, as there are atoms in 12 grams of carbon-12. Okay, so why are we picking on carbon again? Well, by definition, it has 6 protons and 6 neutrons, just like we talked about with atomic mass, but it was determined that the number of particles or the number of carbon atoms that you have in 12 grams of carbon-12, there are 6.02 times 10 to the 23rd particles or atoms in 12 grams of carbon-12. And this number actually has a special name. We call this Avogadro's number. Okay, and so anytime we have a mole of something, we've got that number, 6.02 times 10 to the 23rd. So anytime we have a mole of something, we have exactly 6.02 times 10 to the 23rd of that object. Okay, so let me give you an example. One of my favorite candies is peanut M&Ms. So if I wanted a mole of peanut M&Ms, I'd have 6.02 times 10 to the 23rd pieces. Okay, if I had a mole of paper, that would contain 6.02 times 10 to the 23rd sheets of paper. And then if I had like a mole of hydrogen atoms, that would be 6.02 times 10 to the 23rd hydrogen atoms. So we could be talking about M&M pieces, we could be talking about atoms, we could be talking about sheets of paper, whatever you want to talk about. Okay. Now that we talked about now that we talked about the mole and we talked about how we calculate average atomic mass, now we can define something called molar mass. This is the mass in grams of 1 mole of atoms or molecules of a substance. Now, the way that we get this is that we look at the periodic table. Now, even though the periodic table is reporting the average atomic masses, they also represent the atomic mass of 1 mole of atoms in grams. So we can use those numbers to help us convert from grams to moles. All right, so let me give you an example. So here's a problem. How many moles of magnesium are there in 87.3 grams of magnesium? All right, so in order to solve this problem, we've got to figure out what we know and what are we trying to find out. So what do we know? We know that we've got 87.3 grams of magnesium. What are we trying to find out? How many moles of it do we have? Okay, so this one's pretty nice because we're going to make this happen in one step. In order to go from grams of magnesium to moles of magnesium, the thing that we're looking for is the molecular weight or the molar mass. Okay, and so to look that up, we have to go to the periodic table and find the molar mass of magnesium. And it turns out that the molecular weight, the molar mass of magnesium, is 24.3050 grams. Okay, so that's where we get that from the periodic table. Okay, so to make this work, to do this calculation, we're going to use something called dimensional analysis, where we write things as fractions. So the first fraction I'm going to write, we're going to start with what we know. So on top, I'm going to write 87.3 grams of magnesium. And what I'm going to do is write this. I'm going to put that as the numerator, and this is going to be over 1. I'm putting 1 as a denominator mainly because I want to keep everything neat and tidy. I want to make sure that I understand that this is a numerator that I'm dealing with. All right. Now, here's the thing. In order for this problem to work, I need to put grams of magnesium on the bottom. All right. So we've got the molar mass right here. So for every 1 mole of magnesium, that's going to be equal to 24.3050 grams of magnesium. All right. So for this to work, I need to put that mass on the bottom. Because watch this. If I put that molar mass on the bottom, 24.3050 grams of magnesium on the bottom, and I put 1 mole of magnesium on the top, look at what happens with the units. I can cross out the grams. They cancel each other out, and I'm left with moles of magnesium, which is the unit that we're looking for. Okay, so what I'm going to do math-wise is that I take 87.3 and divide it by 24.3050. Okay, and so if I do that math, the number I get is 3.591853 moles. That's great. Now, there is one more problem that we got to deal with, and that is sig figs. So in this problem, we started with 3 sig figs, 87.3. All digits are significant. So I've got to report this answer with 3 sig figs. So to report that, I would write this as 3.59 moles. And there you go. That would be the answer to this problem. All right, so now that we talked about molar mass, now let's talk about molecular mass or molecular weight or formula mass, however you want to call this. This is the sum of all the atomic masses in a molecule. So for instance, if I wanted to know what the molecular weight or molecular mass of methane is, we take, in order to calculate that molecular weight, we're going to take the mass of carbon, which is 12.011, and we know that in methane, you've got 1 carbon, so I'm going to multiply that by 1. Okay, so that gives us 12.011. You've got 4 hydrogens, and the molecular weight of hydrogen is 1.00794. And if I multiply that by 4, the number I get is 4.03176. If I add those two numbers together, 12.011 plus 4.03176, that mass comes out to be about 16.04 grams per mole. Now, wait, you're saying, wait, Jim, you're going out to 3 decimal places with carbon. And then you got 1, 2, 3, 4, 5 places with hydrogen. So what we usually do for molar masses is that we just take it out to 2 decimal places. So anytime you're calculating a molecular weight, you just have to take it out 2 decimal places and cut it off. You're good. All right. So that's how we calculate the molar mass of a molecule. So in order to calculate the molar mass, you've got to know what compound or what molecule you're dealing with. All right, so let's try a problem here. All right, so calculate the number of moles of chloroform, which the molecule is CHCl3, and 198 grams of chloroform. All right, so for this problem, we actually have to calculate the molar mass of chloroform first. Okay, so let's do that first. We know we got CHCl3, so you've got 1 carbon, so that's going to be 12.011 times 1, which gives you 12.011. You got 1 hydrogen, so that's going to be 1.007 times 1. That's nice. And I just tacked on an extra 0, so I apologize. Let me rewrite that. 1.007, 1.007. All right. Now, Cl. You got 3 Cls, and that's going to be 35.45 times 3, 106.35. And so if I add these all together, 12.011 plus 1.007 plus 106.35, the final mass that I get is 119.37 grams per mole. So that's going to be your molar mass of chloroform. Now, what we're going to do is something pretty similar to what we just did in the last problem. And so we know that we've got grams. We've got 198 grams of chloroform. We need to convert that to moles of chloroform. So we're going to set it up the same way. We're going to start by writing a fraction, 198 grams of CHCl3 over 1. Now, I need to make sure that grams of chloroform goes on the bottom of the next fraction, and 1 mole of CHCl3 goes on the top, so that way the grams cancel out. So I'm going to use that molar mass that we just calculated, 119.37. I put that at the bottom, so that way the units cancel out, and the unit that we're left with is moles of chloroform. All right, so if I take 198, multiply it by 1, and then divide it by 119.37, I should get something like 198 times 119.37. I get, I did that wrong, 198 divided by 119.37. I get 1.6587, and I keep going. Again, because I have 3 sig figs here, I need to make sure my answer has 3 sig figs, so this would be 1.66 moles of chloroform. And so that's how you would do that problem. All right, now let's try something a little bit more tricky. This is not tricky, just a little bit more difficult. Let's take this up a notch. Okay, so here's our problem. How many hydrogen atoms are there in 72.5 grams of isopropanol? All right, so here's what we're going to know. Here's what we're going to do. We know that we've got grams of isopropanol, which I'm going to shorthand it as iso. Okay. The first step is that we're going to have to convert this from grams of iso to moles of iso. Once we're in moles of isopropanol, there's 2 different ways that we could go about this. You're going to get to the same answer either way. Okay. All right, so we could say from moles of isopropanol that we can figure out how many moles of hydrogen are needed to make 1 mole of isopropanol. Okay, once we know moles of hydrogen, we can convert that to atoms of hydrogen. And that gives us the answer that we're looking for. Okay. The other way that we could go about this is that once we know moles of isopropanol, we could figure out molecules of isopropanol. And once we're in molecules of isopropanol, we can get to atoms of hydrogen. Either way you go, it's going to give you the same answer. All right, so now we got to think about, we're going to do this in a couple steps, but we need to make sure that we have all the information that we need to make this problem go. So for the first step, where we're converting from grams of isopropanol to moles of isopropanol, the thing that we need there is the molecular weight of isopropanol. Okay. Once we have the molecular weight of isopropanol, then we can convert from moles of isopropanol to moles of hydrogen. So to make that work, if you think about it this way, in this compound, if you have one of these molecules, if you have 1 molecule of isopropanol, that means you need 8 hydrogen atoms to make 1 molecule of isopropanol. Okay, so if I was to make 1 mole of isopropanol, I still need 8 moles of hydrogen to make this 1 mole of isopropanol. So that's my number. It's going to be a ratio of 1 to 8. Okay. Once I convert from moles of isopropanol to moles of hydrogen, then I can use Avogadro's number, 6.02 times 10 to the 23rd, and convert from moles of hydrogen to atoms of hydrogen. Okay, so that's if I go the top way. Now, if I go with the bottom, where I go from moles of isopropanol to molecules, then I would start with Avogadro's number here, 6.02 times 10 to the 23rd. And then to go from molecules of isopropanol to atoms of isopropanol, that's going to be my ratio of 1 to 8 again. So either way you go, you're still going to have the right answer. All right, so let's try this out. Let's put this all together. So what do you know? You know that you've got 72.5 grams of isopropanol. Okay, we need to convert this to moles of isopropanol. Now at this point, I know we just went over how to calculate a molecular weight, but I'm going to assume that you've got that down. So the molecular weight of isopropanol comes out to be 60.10 grams of isopropanol, and that gets you 1 mole. Okay. Now, in order to convert this from 1 mole of isopropanol to molecule of isopropanol, you've got to have Avogadro's number. So I'm going to make sure that mole goes on the bottom, and I'm going to write 6.02 times 10 to the 23rd molecules of isopropanol on the top. So that way, grams of isopropanol cancel, moles of isopropanol cancel. We're in molecules. Okay. Now, to use that next ratio, I have to convert from moles of isopropanol to molecules of isopropanol to atoms of hydrogen. So for every 1 molecule of isopropanol, you need 8 hydrogen atoms. Okay, so that way molecules of isopropanol cancel out. And look at that, the unit is right, it's 8. All right, so we're at hydrogen atoms. All right, so if you multiply 72.5 times Avogadro's number times 8 divided by 60.10, the answer that I get is going to be 5.81 times 10 to the 24th hydrogen atom.